Hello everyone, welcome to lesson 7-2, Congruence. In this lesson, we will continue to discover ways to determine congruence and similarity, and we will use words such as, or expressions such as corresponding parts, and a math symbol that will be frequent is congruence to, so this symbol right here means it's congruence to. So it's an equal sign with an approximation sign. Real world link. Crafts. Lauren is creating a quilt using the geometric pattern shown. So we have this quilt right here, and you can see that these are all 3 different fabrics. She wants to make sure that all the triangles in the pattern are the same shape and size. Okay, so all the triangles, I see these 2 triangles, 1, 2, and inside here a parallelogram. What would Lauren need to do to show the 2 triangles are congruent? Well, as we've looked at previous lessons, we can take one and it looks like it needs to be rotated 180 degrees, correct? 180 degrees. We can do it on the same point, right? So let's say we were to do it on, let's say, the A vertex, and we rotate it clockwise 180. And then we would need to translate it up positively, right? What would Laura need to do? So let's see. Simply put, we can simply measure the sides and angles of each triangle and then compare them. So we can measure line C to A, line B to C, D to F, and F to E, and we can measure those, and if they're the same, then our hypotenuse should be the same, right? Question 2. Complete the lists of parts of triangle ABC, and triangle DEF, DEF. Then draw lines between the corresponding parts of each triangle. So let's see here. We have line CB is the same as CB will be the same as FE, line FE. So we want to go ahead and draw a line and we write FE, right? Line ED right here, line ED will be the same as line BA. So I can go right ahead now and just start matching the lines, right? The one that I'm missing is line CA. So you can see right there, line CA is missing from here, so I'll write it in there. Line CA will be the same as line, this line right here, CA will be the same as line DF. Line DF. Okay? And then that's how we say when we have a line on top of the letter, we say line. But this one over here, the symbol is angle. So we have angle BAC. The letter in the middle is the angle. Okay? So BAC. So this is the angle we're looking at. Okay? BAC. Right here. It's going to be the same angle as FDE. Right there. Right? FDE. So we have to write that one in. BAC is going to be the same angle as, or you could say EDF. EDF, as they wrote it here. So we can go ahead and match those 2. There we go. And then ABC, angle ABC. ABC. So this angle right here is the same angle as down here. ABC is going to equal DEF. Okay? So we can write it in here, DEF. It's the same as ABC. And now we're missing 2 angles. Angle C will be the same as angle F, correct? So we can write angle C, angle F. And we match those 2. Question 3. Suppose you cut out the two triangles and lay one on top of the other so that parts of the same measures were matched up. What is true about the triangles? Well, we can see they are congruent. Let's look at the main, or one of the key points for today. Main point of this lesson: corresponding parts of congruent figures. In words, if two figures are congruent, their corresponding sides are congruent and their corresponding angles are also congruent. So what we mean by that is this line here, the hypotenuse of this right angle triangle, is being labeled with 3 lines. If we label it with 3 lines, we should also label this line with 3 lines because they are congruent. This symbol states that they are the same. This one right here, the same as this one. So we label it with 2 lines. We mark it here with 2 lines, and here with 1 line. We mark it with 1 line. That's the way to mark them. We're saying that this angle here with 2 little lines is the same as this angle, and this one is the same as this one, and we can see that they're both right angles. And clearly we have a reflection over the y-axis. So in symbols, we would say triangle ABC is congruent to triangle DEF. Okay? Congruent angles, and we see here the congruent angle. Angle A is congruent to angle D. Angle A is congruent to angle B. That means angle B is congruent to angle E, correct? Does it say that? Yes, right there. And angle C is congruent to angle F. Does it say that? Yeah, right there. Okay? And then we can also do congruent sides, the lines, which means line AB is congruent with line DE. Is that correct? Yes, it is. And you can see that we continue to label it like that. In the figure below, the two triangles are congruent because triangle DEF is the image of triangle ABC reflected over the line M, or our y-axis. The notation triangle ABC is congruent to triangle DEF is read triangle ABC is congruent to triangle DEF. As you can see, this means it's congruent to, right? This symbol there. The parts of the congruent figures that match or correspond are called corresponding parts. AB is a corresponding part to DE, or line AB is corresponding to line DE. Write congruent statements comparing the corresponding parts in the congruent triangle shown. So essentially what we're going to do is we're going to practice how to write congruent and corresponding angle statements. Use the matching arcs to tick marks use the matching arcs and tick marks to identify the corresponding parts. Corresponding angles, you can see here, angle J is corresponding to angle G. Angle J is corresponding to angle G. Okay, it looks like we have a reflection and then a translation, right? And you can see that they've done the same with the lines. Line JK is corresponding to GH. Line JK is corresponding to line GH. Because it's a reflection, these two lines are closer and these ones are farther apart. And you can see how the tick marks have been used to label this line is corresponding to this line, and this line here, line IH, is corresponding to line LK. All right, here's our first example. If you think you know how to do it, please pause the video and go ahead and find all the corresponding angles and then find all the corresponding sides. Go ahead and pause now. Okay, I hope you paused the video. Now we can see here that if I were to start with angles, first I have to identify how the pre-image was translated and became the image, right? So I can see that it's a reflection over the y-axis, and I can see now, judging by the ticks on the lines, that these two are corresponding lines, so these must be corresponding angles. So angle A is corresponding to angle M, or you can say it's congruent to. Angle A is congruent to angle M. And then we follow along. Angle S is corresponding to angle angle P, and angle K is corresponding to angle O. Angle B is corresponding to angle N. And then we can do the same with the sides. Okay, remember the line. Line AB is corresponding to line MN. Line BK is corresponding to line NO. Line KS is corresponding to line PO. And finally, line SA is corresponding to line M. And it should look something like this, where I've gone through all these angles, and then I separated them, and in a different section we have all of the corresponding lines being matched. Okay, so your answer should look similar to this format. Okay, now we can take our new skills and apply them to the coordinate plane. Example 2. Triangle ABC is congruent to triangle XYZ. Write congruent statements comparing the corresponding parts, then determine which transformations map triangle ABC and triangle YXZ. And we can see that triangle ABC, triangle XYZ. It looks like we have a reflection over the y-axis, right? And then a negative translation. If we're going from this image, if we determine this to be our pre-image. Sometimes they might determine this to be the pre-image and this the image. So we'll see. Okay? Analyze the figures to determine which angles and sides of the figures correspond. Well, we can see that these two, line AB corresponds to line XY. Line BC corresponds to line YZ. And line AC corresponds to line XZ. You can see that, right? So there it is. It's all labeled for us already right here, just as we mentioned them. Okay, in two different sides, corresponding angles and corresponding sides. Then step 2, determine any changes in the orientation of the triangle. The orientation is reversed, so at least one of the transformation is a reflection. Yes, over the y-axis. We already mentioned that. If you reflect ABC over the y-axis and then translate it down 2 units negatively, it coincides with triangle XYZ. Now we know this, but can we replicate this? Can we do this ourselves when we see a question like this? That is the skill being learned today. If you see a question like this, are you able to create an explanation like this, at least from here? If you reflect and then translate, you would have to explain how or justify how they're congruent. The transformations that map triangle ABC onto triangle XYZ consist of a reflection over the y-axis followed by a translation over of 2 units down. This right here, boys and girls, that is the answer. That is the skill you have to have today. Okay, so now here's a challenge for you. We have 2 parallelograms. Okay, parallelogram WXYZ is congruent to parallelogram KLMN, as you can see. Here's our pre-image, and it's congruent to our image here. Write congruent statements comparing the corresponding parts, then determine which transformations map parallelogram WXYZ onto parallelogram KLMN. So there's 2 parts. As you can see, they want you to write the congruence, right? The corresponding angles and the corresponding sides. And then later, they want you to determine the transformations. Were there any rotations? Were there reflections or translations? So go ahead and pause the video and go ahead and try this on your own. Pause now. Okay, I hope you paused the video so that we can see, so that you are able to challenge yourself. Okay, let's see. If this is a reflection, that means this line must be this line, right? It's been translated over. But if I reflect, this image over the y-axis, okay, it's going to be there, correct? One away from there. So that means I would have to add 1 to and translate it over to the right. So not only am I reflecting it over the y-axis, then I have to move it to the right 1. You see, so that it's a line there. Once I've moved it to the right ones, I have to drop it down or negatively take 1, 2, 3, 4. 4 down. Correct? So another way you could do this, and you might have seen it already, is to reflect it over the x-axis. If I reflect it over the x-axis, right, the y over here will be exactly negative 1 down from the 2, right there. So I won't have to do 2 translations as I showed you up here. I will only have to do 1 to the left, 5 units to the left, it looks like, right? Because if my y becomes here, my y will now be my m. So I will go 1, 2, 3, 4, 5. 5 to the left. So yes, I think that one will be easier because I have to do one less movement, one less translation. So I will reflect it over the x-axis and then move to the left 5 units. So that means then if I do that, that y, z, the line yz is corresponding to line m, n. And ZW is corresponding to NK. Okay? Just try to picture it, reflecting it, and then translating it. So your answer should look something like this. Your corresponding angles should be the following. Angle W is congruent to angle K, angle X is congruent to angle L, angle Y is congruent to angle M, and angle Z is congruent to angle N. Okay, and then your corresponding lines are as following. Please feel free to pause the video and check your work. Okay, and then what do we do to move it? Well, I think the easiest way would be the reflection over the x-axis and then a translation of the 5 units, right? Or if I do a reflection of this image, let's say this is my pre-image, and I do a reflection still off my y over, and then I move it over to the right. I could do it that way too. So it could be a reflection over the x-axis to the top, and then move it to the right, or to the bottom and move it to the left. There are many ways we can move this around, like moving around furniture. So I will use this one as the book dictates. It's a reflection over the x, and then 5 units to the right. So yes, reflect KLMN, KLMN over the x-axis. So we're going up, and then translate it 5 units to the right to coincide with parallelogram WXYZ. Pause the video if you need to copy this down. You can also use the skills we've learned to find missing angles. As you can see here, find missing measure. That's another key concept for today. You can use properties of congruent figures to find the missing measures of angles and sides in a figure, which means if you understand that this triangle here, this right angle triangle, is congruent to this right angle triangle, you can use the measurements from any of these angles or sides to identify the missing angles or sides on this side. Correct? So for example, Miley is using a brace to support a tabletop. In the figure, triangle BCE is congruent to DFG. If angles CEB, so this is the angle we're looking for, is 50 degrees, right? It's the middle letter is the angle. What is the measure of angle FGD? FGD. Well, it looks like this is a reflection over the y-axis. So angle E is congruent to angle G. So if it's 50 there, it's going to be 50 here, right? If E is 50, G will be 50 as well. And there it is. That's how they respond. Okay, so I think we can try this now as our last example. As you can see, the guided practice is next, so we are almost done here. Okay, In the figure shown above, the length CE is 2 feet. What is the length of FG? Or the line, sorry. I always use the word length, but line. Line CE is 2 feet. Line FG must also be 2 feet because we're using congruent angles. And in order to maintain this angle here of 50, okay, we can only move 2 feet away. So we would have, this would also have to be 50. When we make this angle 50, it'll match here. The vertex will be at 2 feet. So simply 2 feet is our answer. Okay, here is our guided practice. We only have 2 questions to start class with. Make sure you feel comfortable with the content. If you have any questions, please bring them to class. See you then, everyone.